So let's get started. Today we're going to be talking about attacking cloud services with source code. My name is Jonathan Claudius. I work for Trustwave SpiderLabs, and I'm a researcher there. I work in the vulnerability assessment team. So the focus of the team that I work on, we basically POC vulns. We take those vulnerabilities and we turn them into viable checks for our vulnerability scanner, and then it allows our customers to go and scan their networks and find those vulnerabilities. So that's what I do at work. Outside of work, I'm an open source contributor, most of which is in Ruby. It's the language that I'm most familiar with right now. However, there's other languages that I've contributed to as well. So that's me. Today, what we're going to be talking about is sort of, there's two major sections that I want to talk about today. There's sort of a developer side of this, and there's sort of a attack security side of things. And we're going to need the developer side before we get to the attack stuff. So for those of you that start seeing the beginning of this, like, wow, this guy's talking about all this developer-y, codey stuff, I want to ensure you that at the end there's going to be some cool stuff. So I don't want you to leave midway saying, oh, well, that guy was just talking about developer stuff at a security conference. But at the end, we'll have some demos, questions, and then I don't have it listed here, but there's a tool that we'll be talking about that I'm going to release. So basic terminology and concepts. The first thing I want to talk about is continuous integration. Can I say a quick raise of hands of who knows what continuous integration is? Heard of it, used it in your environment? Okay, for those of you, thank you. But for me, continuous integration, and I've got the definition up there for you, but what it means to me is that every time I make a commit on a project, if I'm making edits as a developer, anytime I make a commit, it triggers something on the back end that checks out my code, it builds my code, and it tests my code, and validates whether or not it's good or not. Does that make sense? All right. So one of the popular examples that I'll be talking about through here is Jenkins CI. Has anyone heard of Jenkins CI or used it in your environment? It's a popular CI, and I'm going to use it for the purposes of this talk. I'll use it as an example later. But for Jenkins CI, it's basically a continuous integration server that's open source and free, and you can install it in your environment, and what it'll do is it'll do that checkout, build, and test your code every time you make a change. There's a little bit of work with it, but it's really, really useful, and we use it where I work. The sort of next thing I want to talk about is unit testing. And unit testing, I got the definition up there, but the way I like to think about unit testing is when I take my car into the shop. So when I take my car into the shop, one of the things that happens to my car is it goes through all these multi-point inspections. So think of unit testing as sort of all the things that work on your car. So we're going to check the tire pressure, we're going to check the radiator, we're going to check the doors open, the locks work. We're not going to just jump in your car and take it a ride from around the block and say, hey, your car works just fine, man, I don't know what you're talking about. We're going to test every individual piece in that car and make sure every single piece works. So that's essentially unit testing to me. In Ruby, there's a framework called RSpec. And what RSpec is used for is essentially unit testing your code. So you write code that tests your code and validates that your code works properly. So in this case, I've got an example. Basically, I'm going to run get username, and it should equal my username. If it comes back and it says that it equals root or it equals some other user, in this case, that unit test would fail. So this is essentially the basic structure or the workflow that we're talking about with continuous integration unit testing. We've got a bunch of developers here on the left side, and those developers are rigorously developing code, committing new code all the time, and they're pushing that code up to a central repository. That SCM or source control management solution can be SVN, Git, CVS. These things all familiar? Heard of these things before? What happens is anytime there's a change to the top of that repo, it triggers something on the CI side. So the CI thing sees it and says, okay, there's new code, the project has changed, now I need to build it and I need to test it. So that first process is we check out that code, we build it, we make sure that, like, for instance, if it's a C project, that it builds successfully, it doesn't fail. And then if it actually passes that stage, we pass it on to this unit testing aspect of it, where again, we're taking our car into the shop and they're going to check everything. They're going to pop the hood. We're going to do all these individual tests to make sure that the code is still working after that change to the code. And then what happens is this testing completes, and then we get a report back to development to let development know whether or not the code still works or the code is broken in some way, and gives them feedback as to what's broken so that they can turn around and fix it. And this happens every single commit. So if you listen to the keynote that Gene gave earlier, it's kind of a rigorous process. It happens as the development's happening so that we can constantly find and fix problems that we introduce and ensure that we have a high quality product. So that's some of the developer stuff. I want to talk a little bit about open source development as it pertains to my perspective. Like I said, I consider myself an open source contributor. And there's some really awesome things that come along with open source. I consider it sort of a hobby for me, because it's not something that I can do 8 hours every day. So there are times where I'm writing code in the evenings, I'm writing code on the train, writing code on the weekends. I'm very busy writing code outside of just my normal responsibilities at work. And I really love it because I can solve problems, I get to learn new things, and I get to meet some amazing people through the advent of things like GitHub, where I can put my code out there, people can say, hey, that's kind of cool. And they can play along too. They can contribute to the code, they can add to the code. So those are some of the good things about open source development from my perspective. But everything with a good side, there's always a bad side or a downside. And one of the big things that sucks about being an open source or contributor and not have it be your primary job is that you have a limited amount of time and resources. I don't have all the support structure. I don't have all the servers. I don't have all the QA resources to make sure that my code is good like I do at work. So that's sort of a challenge. The other aspect is everyone can contribute. And in a lot of senses, this is a good thing. I think a lot of people would put this in the good thing bucket. But for me, sometimes when someone's contributing to my project, that also means that they may not necessarily have the same experience level or knowledge about the product or the project. So there's times where I can get sort of crappy code suggested to me. And I don't want to turn that person away because they're contributing to my project, but at the same time, I want to have some objective way of being able to say, hey, your code's not good because of this or that. And I worry a lot about code quality, mainly because for the stuff that I do at work, if I make a mistake, if I write a vulnerability that crashes a server, it's not that I'm going to crash one server, I'm going to crash a million servers that I've scanned over the course of our monthly scanning process for our customers. So I try to take the things that I learn at work and I try and contribute it to the work that I do in open source. And additionally, more relating to what we're going to be talking about today, I didn't have a fancy CI infrastructure. I didn't have something that was going to continuously test my code and verify that my open source projects are as good as my projects that I do at work. So some of the downsides. And the next thing I want to talk about is cloud services. So I was kind of venting to a friend of mine. I was saying, hey, it's challenging for me to be an open source developer and not have all these support tools at my disposal. So I'm constantly worrying about my code. I'm constantly worrying about whether or not I'm going to break my project. So he suggested that this thing called Travis, and Travis is an open source, free hosted continuous integration service. It's not the only one out there. There's a number of other ones out there. Some of these are paid, but they're getting more popular. So you don't actually have to set up your own CI server in your environment like Jenkins. You can actually offload that responsibility to someone else, and then you can spend your time writing code and the things that you want to do, the things that I want to do, without having to worry about all this infrastructure. You don't have to worry about how does it work, how is it set up. You can, excuse me, got burps. You can just hand your code off to these systems and they can start building the project for you and make sure that your code is good and continues to be good as you develop and push your project forward incrementally. So I want to talk a little bit about how it works. First, we've got a developer. For those of you born in the 80s, you know who that is. And that developer is going to be using GitHub to push his project up and host his source code. And he does that change. And then Travis, which is one of the CI providers, is going to be monitoring that that GitHub repo. And he's going to say, hey, is there any changes to this repo? Have there been any updates to this repo? And when that happens, Travis will basically start a process on his end. And this is sort of where it gets a little bit different than that simplistic flow that we looked at earlier. Travis is not actually going to be building your project. What he's going to do is he's going to hand that project off to a worker. And those workers can be from any different, they can be from a variety of different organizations that offer up build services for free, because again, we're talking about open source projects. We're talking about all this happening with no money exchange. So what happens is that when Travis triggers that there's been a change, he delegates that work to that worker. So it might go out to EngineYard, which is one of the providers on Travis, or one of the CI providers. It might go to Heroku, and it may go to any number of providers that they partner with. So it's kind of weird. You don't necessarily know where your code's going to go, but it's eventually going to land somewhere, and it's going to get built, and it's going to get tested, and at the end, we're going to get a report back to the developer to let them know whether or not that code passes or fails. And this happens every time we make a change. So from my perspective, as an open source developer, this is a really good thing. This means that anytime I make a change, I know that as long as I've done a good job speccing my code and doing good unit tests that validate how my project works, I know that I'm not making a regression here. So I'm not stepping backwards, I'm always moving forward. So I want to talk about the setup a little bit. It's pretty simple. Basically, you go to travisci.org, and you go in there, and they have single sign-on set up with GitHub, and you just go to your project that you want to enable, and you just flip the switch. And then you go to the GitHub side, and within every GitHub project, there's a thing called service hooks. And if you go into those service hooks, and you scroll way down, because they have a lot of different service hooks that they have available, you select that, and you hit this test hook thing. And what this does, once you've hit, it says payload deployed, that means that anytime going forward, anytime you make a change to your project, it's going to test your project assuming that you have proper unit tests there. So what ends up happening, and this is an example of one of the projects that I have it on GitHub, which is called C7 Decrypt. It's an encryptor and decryptor for Cisco Type 7 passwords, if any of you are familiar with that. But one of the things that was really cool about it was that a lot of the projects that I wrote, they only worked on one version of Ruby, because it just happened to be the version of Ruby that was on my laptop. With Travis, I was able to enable all these different other repos. So now I can, programming languages, so I can get validation that my project runs on the latest version of Ruby. I can get validation that I'm running in JRuby, and I can run on all these different versions with no effort in addition to just checking a box on the project. So that gives me confidence building an open source project that anyone who wants to use this code and using any one of those virtual VMs is going to be able to use my project. And it's going to work the same on all those different frameworks. The other thing that's nice is I get a full build history. So it basically keeps track of all the builds that I've ever made, and gives me the results for every single version of Ruby that I built it on. The other kind of interesting thing, and we're going to revisit this later, and I hope you're paying attention right now, is that it builds pull requests too. And what this means is in GitHub, when I see a project that I like and I want to contribute, I can just say, oh, that's pretty cool. I can fork the project, I can make some changes, and then I can send a pull request to the original author and say, hey, I think this would be a cool addition. Do you want to try this out? And what happens here is that actually it's integrated into that developer's workflow. It gets built and tested and validated that it's good, so that when we go and look at the pull request, not only do we see that the code is clean and that it can go into Git without any conflicts, but also we know that the build passed, meaning that their contribution doesn't break the project, at least assuming that we have good, solid unit specs. All right. So that's kind of the developer side. I'm going to take a second to get a drink of water, and we're going to kind of take that hat off and put an attacker hat on. All right, so I want to talk about this talk that Ben Smith gave. He's a Rails developer, and he gave this talk at Aloha Ruby conference last June, and it was called Hacking with Gems. And what the premise behind Ben's stuff was that how evil could I make a gem and convince someone to install it? So Ben's idea was like, okay, I can do malicious rake files, which are things that are run within Ruby by default if you're running specs. I can do malicious C extensions, so anytime someone runs gem install, I can take over their machine. And one of the really novel things that Ben said during his talk was he put this picture up of a business card that he distributed all through the conference. And basically it just says, gem install Aloha Ruby conference. And keep in mind, this is a Ruby conference. This is not a security conference. So it is very customary in development circles to be able to share code, share ideas, share new techniques. And one of the things that came out of this was that a bunch of people installed his gem before his talk, of course. And then during his talk, he described all the people that installed the gem, and all he did was grab the username. But during his talk, he talked about all these evil things that he could have done if he wanted to. So I thought Ben's talk was pretty cool, and it really got me thinking about what are the things that could I do that sort of springboard off of Ben's idea, and it was sort of the impetus for giving this talk. And one of the assumptions, like I said before, about Ben's talk was that it assumed that there was some social engineering aspect. There's something that I need to do to convince you to install my code. The other aspect of it was there needs to be some assumed obfuscation of the code. So when I look at, so if I'm trying to convince you to look at my code, and I go, hey Todd, please install my code, you might be like, really? But you might look at my GitHub repository, you might want to take a look at my code and see what's going on. Well, with Ben's stuff is that he was trying to be overly sneaky. So he's hiding things in places that people wouldn't look. So my thought was, what if I could guarantee code execution on the target system? What if I didn't have to hide anything? I didn't have to be overly sneaky. I could keep all my POCs extremely simple. And then how can I control when those things happened? So that sort of gets me into attacking cloud services and sort of the impetus behind this. So what happens on a CI server or a CI environment when they're building a Ruby project specifically is that it runs this thing called rake spec. And what run rake spec means, it basically means run all my unit tests. And in Ruby, unit tests are essentially just more Ruby code. So there's nothing stopping me, there's no like DSL that I'm conformed to from just putting malicious code in there. So that's sort of the impetus behind this. What happens if I take malicious code and I give it to these systems that are trying to help me build my project better? Could I attack those systems? Could I gain access to those systems? Could I do evil things with those systems? So again, we got this example here. This is sort of how the cloud services work. We pass our code up to GitHub, it goes to Travis, and then it gets distributed down to these other systems as they are available. So my thought was, okay, if I can get malicious code up onto GitHub, and then I could update that commit, Travis is going to be looking at GitHub, see that there's new code, that code's going to get pushed down, and then I'm going to get malicious code on all these different build instances. And there's a lot of these. In the testing that I just did a basic kind of where am I every time I built the project. And one of the things that was kind of interesting is that I'd pop up in Germany one day, or I'd pop up in Brazil on a different day. And it really depended on just sort of randomness as to where I would pop up, but I'd always be on a different box. So if I could get this malicious code on every one of these boxes, I could build a pretty nasty botnet. So in lieu of that idea, I decided to build my own CI server because as a developer, I really enjoy being able to use GitHub. I really enjoy being able to use these Travis CI servers. So I didn't want my accounts revoked, and I didn't really want to do any bad things to them. But what I did want to do is I wanted to try it out. I wanted to see if I could emulate this kind of stuff in my environment and go from there. So I ended up using Jenkins, and I have a pretty simple setup. It's just me and GitHub, and I'm using a private GitHub repository now. And I push code up to GitHub, and then I have my Jenkins CI server pull GitHub to see if there's any changes. And if there's changes, it'll pull down that code and run that code. So here's the awesome thing about this, and I think I've hinted to it already, is that you don't have to be overly crafty to do bad things on these servers. They're designed to be open, and they're designed to sort of be flexible for different developers so that if you want to do something different with your project, there's not a lot of configuration that's required. So in this case, I can do basically just a simple, jump 2 directories above where I currently am and see what happens. Like, what is the result of ls 2 directories above me? And one of the things that's interesting is there's very little sandboxing on some of these environments. So you can do stuff like this. I can see not only am I building my C7 decrypt project, but I'm also building all these other projects that are going on this server. These projects might be mine. They might be someone else's secret sauce. That might be Pepsi's secret recipe in a Ruby project. So these things are possible. We can actually jump out of these directories. We can also dive into these directories and see what source code's in there. We can access the source code, read it. We could even export it off the box. So the other thing I thought about was, okay, what if I could pivot? What if I could use my position on the network from within the CI, and could I attack neighboring devices? Could I go and see what's there? Could I go and attack other devices that are outside that network? And the answer was, of course. We can do port scans and see if there's other devices that are neighboring to that device. And perhaps if there's vulnerabilities on those systems, we could jump to that box, exploit that box, and then keep moving forward if we're thinking it from the pen test methodology. The other kind of, this one was really interesting, is like, with these devices, there's a lot of trust, or there's an implied trust that they're going to be doing good things, so they need to be able to get to your repository and check out your code. So if you have a private project, it's going to need the SSH keys to properly get to your project. Or if you're going to be stamping any build numbers, so like every time I build a project, I'm going to update the build number, I need to be able to connect back and authenticate back to GitHub. So in this case, with these SSH keys, they can be read, and they can also be read-write. So one of the implications here is that if I could read-write, if I built your project, could I turn around and make a commit to your project maliciously and Trojan your source code repository? So, of course, in this case, if you've ever set up a GitHub account, one of the first things that you do after you get your SSH key access set up is that you perform an SSH and you connect to GitHub, and it'll basically respond saying, hey, you've authenticated as this user. So those are sort of the things that I'm thinking about as I'm going through this, and I'm like, wow, this is crazy. And I'm trying to do all this in code, so it's a lot of trial and error. It's like, oh, well, I forgot to put a timeout in the SSH command, and my build's going to run forever, these types of things. But then I just got sick of it, and I was like, okay, well, reverse shell. What if I wanted to just do a reverse shell on this machine? What if I could just get command line access to the server and stop wasting all my time trying to do this in code? So I'm referencing pentestmonkey.net here. This is actually where I got this Ruby backdoor or reverse shell. The reason why I'm doing that is because he puts it, or I don't know if it's he or she, but they put it in various different languages. So you can get it in PHP, Java, you name the language, there's the type of reverse shell functionality there that we can use to get access to the box. So I'm doing all this in Ruby up to now, but there's nothing to say that if I wasn't building a PHP project or a Java project or some other language, that I couldn't do something like this on a CI server. So I do have some demos prepared for you guys. The first one is what I would consider sort of the basic example. This one is, we're going to take a look at actually popping a shell on a CI server. How can I make this bigger? Yeah, you guys can see that okay or no? If you can't, you can move forward a little bit if you'd like to see. I'll also make the videos available online afterwards. So here's what we've got. Basically, here's a public project that I have. It's called C7 Decrypt. It's on GitHub, and what I've got is I haven't made any change to this project in 25 days. And the latest spec here says removing test spec. So that happened 25 days ago. And what I'm going to do is I'm going to switch over to a command prompt here in a second. And we're going to make a change to this project. So I just created a demo branch, and we're going to jump into the specs. I know it's really hard to see on the screen, but this is sort of what specs look like, or our spec looks like in Ruby. It basically defines all the different tests that we're going to want to do on that code. This is how this method works, this is how that method works. But like I said, it's just Ruby. So what we can do is, instead of just putting tests in there, we can actually just inject malicious Ruby, kind of unadulterated, unobfuscated Ruby, right into the spec. So what this can do is that if we feed this to the CI system, we'll get a shell. So let's see if that actually works. So we got to basically diff that code. We see that we've added the reverse shell to our specs. And we're going to commit that code. Can I have a reverse shell? Commit message. We'll push that code up to GitHub. And then if we go back to the project, we'll see that the commit now is the top of the repository is, can I have a reverse shell? So we've got our code in our GitHub repository, and we've pushed that code just now. So the next thing that we're going to do is we're going to fire up a reverse handler in Metasploit just to catch our shell. And it's listening on 443 because maybe there's something that we need to get out behind a firewall perhaps. And then we're going to switch over to Jenkins. And this is the CI server, and you can sort of see here's all the different build histories. So every time we build that project, we get that same view that I was talking about in Travis, where we can see all the builds. In this example, I'm building the project manually just for time's sake. But in a real environment, what's going to happen is that CI is going to automatically trigger. So this step won't necessarily be required in environments where someone was trying to exploit a CI server, but it's good for demo because it goes fast. So as we can see, there's another build that's sort of pending, kind of getting going, and we can actually watch that build as it checks out our source code. And what happens is it'll check that code out, it'll build the project, and then it'll start to execute those specs. And when it executes those specs, we'll actually get a command shell from the target system. And we can dive into that shell, and we can utilize that shell and again, it's a little wonky at first, but I don't know if you can see this, but this is the root directory where my code is checked out on the build server. So we've successfully attacked that server. We are in the Jenkins job workspace. So like I was showing you before, if you back out of this directory scheme, we're going to be right about here, and we'll be able to see those other projects, access those other projects, and interact with those projects. And in this case, my user is Jenkins. But a lot of these CI providers, what happens is they provide what they call passwordless sudo. And what that means is that you can jump to root without needing a password because that might be required for a project to be built or a project to run. Like, for instance, in cases where you have a project that might need to touch network I/O or things like that. So it would be very easy to root one of these systems. Something to keep in mind, though, is that these systems are sort of temporary. They spin them up and they spin them down quite quickly. I have found some ways where you can get on the box, and as soon as you pop a shell, you hold execution state. So you'll have maybe 10 minutes to 30 minutes. On Jenkins, this time seems to be a lot longer, but you have a long time to be able to sort of do what you need to do, and then as soon as you exit the shell, the test will continue to run. And as long as you don't muck with the specs themselves, the specs will continue to pass. And the developers won't hear that kind of ringing bells that there's a guy doing malicious stuff if you don't actually affect the specs. Yeah, smiley face. So that's number one. I should have been here and told you that I'm a malicious person and I want a shell on your box. This one, it was to be recorded, but it has been recorded for today. This one's a little bit more evil. So I realize that a lot of these systems, they're temporary. They're designed to be this way, and I was acknowledged that in the previous demo. But what if I could persist somewhere? Maybe I won't persist on the box. Maybe you've done all the right things to stop me from accessing the box. You've segmented me. But what if I wanted to be a really bad person? What if I knew that your CI server was building pull requests? And what if I sent you a malicious pull request that contained this type of stuff? Would you build that on your server? Would I get code execution? And what if you put the wrong type of key on your box and gave me read-write access to your repo as opposed to read access to the repo? What would happen? And that's what I'm going to show you here shortly. And what this basically means is that we can make a commit to the project's master branch. In development, at least on Git, Master is like the holy grail branch. It's the branch that we always want to be buildable. It's what a lot of projects will use when they say, hey, check out my code, or hey, get the latest version. This is where that is. This is where a lot of the packaging starts. This is where different repositories will grab your project, turn it into an RPM or a DMG or whatever for other people to install. So if you affect that branch, you could cause some really bad havoc if you get into a popular project. So I do have a demo for that. It's sort of not as exciting as I wanted it to be, and I'll explain why. Where am I? Can I just get you to open up? There you go. So this one's a little bit different. So what I've got here is I don't actually have a pull request. Mainly because I was having a really hard time trying to get this working on Jenkins. And actually one of the reasons why I started using these CI services instead of using Jenkins, because I didn't want to have to figure it out. So what I'm going to do here is I'm going to make a commit to another branch that I have access to. But in the context of CI services, this is no different than a pull request if you're automatically building pull requests or you're automatically building another branch as opposed to master. So what we're going to do, again, we're at this master branch. It hasn't been touched in 25 days. And we're going to go make a change. But we're going to do it in a separate branch than master. So we're going to go over to the demo2 branch. Again, it hasn't been touched in 25 days. The exact same copy of what's on master. And then we're going to go make that change. So again, this is just the C7 decrypt specs, nothing exciting here. But we're going to add something that does a little bit more. So I'm going to pause this and I'm going to talk through this because I know you guys can't see it. I've got an array of commands up here, and I'm going to tell you about what each and every one of those does. We're going to create a directory in the root of the project called testing. And then we're going to clone that repo again into that directory. We're going to go into that directory and we're going to make a malicious change to a file, and then we're going to commit that change with a commit message of test just to validate that we've successfully done so, and then we're going to push that back up to the master branch while we're building in an alternate branch. So this is basically jumping from a branch commit or a pull request commit into master and attacking master. And then again, we have just a little bit of code here to join all those commands together and have them execute as one. We're going to write this to disk at some point. There you go. We're going to commit it. And one thing to note here is the commit messages are going to be different. There's going to be a commit that I'm making, which is introducing this bad code. And then we're going to have another commit called with a commit message of test that shows that we've actually successfully made a malicious commit to master. So we're pushing that up to the demo2 branch. And we're going to look at the GitHub repo and make sure that demo2 has got the latest commit. And of course it does. It says make commit to master that we just made. And we're going to go over to Jenkins and we're going to kick that build off. And again, this build is automatic in a lot of these cases. I'm just doing it because I didn't want to get into a recursive commit loop. So in this case, we're just waiting. I'm going to go kick that build off. And I'm actually show the build process here so it's a little bit more clear. But what happens is we're going to actually check out that demo2 branch. So that's who we're building now, not master. And it sort of goes kind of fast, so I do roll back up at the end and we kind of walk through it a little bit. But it's not a very time-intensive process to make a commit and push that commit up. Actually, you can see it right here. So what happens is, let's see. So we've already checked the project out. We're making that change to the README, and then we're pushing that change to master. So in this case, it actually shows that we've made a change to master from that built branch. So it sort of like completes really quickly here. We go back up. I have really small specs for this. But what this shows is that we've actually made a change to master. We've Trojaned the master branch for that GitHub repository. And we'll go back to the repository and actually validate on GitHub that we've actually Trojaned it properly. So if we go back here, we're looking for a commit of test on the master branch, and there we go. So that's us being able to jump from one branch to another. Conceivably, it could have been a pull request. I just did it in a branch. But we've actually made that change to the master. So that means that if someone was to package my project and they were to build it into a Linux repo, this is where everyone would go to get my code and build those RPMs and build those DMGs. So if I did it on a project that was really popular, like Ruby, or something like, obviously, Metasploit, for example, because they also use these types of services, we could potentially get a malicious commit into that project and have it do havoc on all its users. So that's demo number 2. So up to this point, I've talked on the developer side, and I've talked on the offensive side. I want to talk a little bit on the defensive side for a moment. So what I did is I spent a little time thinking about this, and I was like, what's the best way to solve this problem? And the only thing I could think of was actually starting to test the CI services. So I created a project called Rotten Apple. It's not currently available yet. I probably have it available in the next week or so. I'm actually moving to Boston, the Boston area, in the next week or so I'm just a little bit bogged up. But the idea here is that when we have a CI server test our code, or checks out and tests our code, it's validating that our code is good. What I'm doing is I'm writing code that will test the CI server while the CI server is testing the code. So it's sort of a role reversal here. And the idea is that if we're doing the right things, we're going to get a bunch of passes. Perhaps if we're doing the wrong things, or we're doing things that could allow our CI server to get attacked that we're not comfortable with, we would then throw fails for those particular types of specs. And again, I'm thinking sort of on both sides of this. I can think of the audit framework being useful. So if you're a developer, you're a CI provider, you could run this on your project or in your environment, to validate that it works properly or it does all the things with a reasonable amount of sanity. But I can also think of attack scenarios where if you're on a pen test and you gain access to a source code repository, or you gain access to a developer's workstation, you might actually be able to make malicious commits to their project and attack additional build infrastructure. And you can also sort of chew into their, say that, for instance, they have one server that does all the CI. That means that every single project that's being built in that company could conceivably be within scope of someone attacking just one repository. So these are some of the things that I think about. I'm hoping that developers, quality assurance folks, system admins, as well as CI providers check this out. I'll probably put something out on Twitter that basically says it's available. I don't have a lot of tests right now, but I'm hoping that folks that are interested in this kind of stuff could contribute ideas or thoughts on ways that we can make CI services a little bit more secure. But again, like I said, there's potential bad things that could happen here. So I'm thinking about what can pen testers do to be able to show that risk to their customers if they get into an environment and they find a GitHub repository or a local Git repo with credentials that are stored with SSH keys. Could they potentially take that and elevate their access to do other bad things and show that risk before the bad guys do? So I have a couple parting thoughts. Like I said earlier, CI servers are open by design. This is not a slight against CI server builders or anything like that. This is the way they were built. So like I said, as far as the attack scenarios, they're extremely simple. They don't require a lot of thought. As you've seen, some of the POCs here were 1-2 line type things. But there are trust relationships here that matter. And they can be abused by bad people if they can understand the kind of the impacts of what happens when someone gets rid of or gives access to a GitHub repository. Or in a case where we're on the open internet and we're using GitHub and we're building a pull request that might not necessarily be validated as good yet. There might be malicious code in there. So as far as the demos go, the CI services, at least the first one where we're popping a shell in the servers, they can be used as a pivot point if leveraged properly. And on the second side, where we're talking about keying problems, a lot of the integrated CI services that GitHub provides, including Travis, who I'm picking on today, actually do this right. They actually use what they call deploy keys, which are different than, say, a user key on GitHub. In GitHub, their user keys, if you're not in an organizational unit, means that you have read-write access by default. So if you're using user keys on a CI, make sure that you're aware of this risk. It's very important because it could mean that the source code within your project could get Trojaned if someone builds a malicious pull request, and that could be really, really bad. Highly recommend using deploy keys. They're just another option that you can choose within the project inside the administrative console within that project. And then the last thing, I'm hoping this is sort of a message to you all for the Rotten Apple project, is that I really think we should be testing these things. We're using these to test our code. I really think that we should use our code to test these, make sure that we're keeping each other accountable. So, does anyone have any questions? Keying is probably the biggest concern that I have, because if and again, I made that mistake myself when I was actually setting this up, so I know that it's possible. But I think the big thing would be keying, and then also, where does that box live? And what does it have, what things are being built on that box? Those are sort of the things that I'm worried about. Can I get access to source code that's a private repository? In the example that I showed you, 2 of those projects are private. So there's no difference once it hits the disk on the CI server. So I'd say make sure that we understand the network segmentation, understand what trust level that particular piece of code has, and then ensure that the keying is clean, meaning that we have read access keys, we don't have read-write keys, because read-write keys are actually, in a lot of cases for developers, they're an incentive. Like, they're things that are good about being able to read or be able to write back to the project, such as stamping build numbers and verification that this code was built in this time frame. So there's incentive for developers to make those read-write. Absolutely, and I think for a lot of cases, the big boys in the room, the big boy CIs that are like doing a lot of these cloud services are actually doing a lot of the right things. So they are doing proper sandboxing in a lot of cases, but not in all cases. So I think the very, very top of the scheme are doing it right, but that doesn't necessarily mean that the guys a couple rungs below aren't doing it right. But I certainly think that from a malware perspective, we need to treat source code as potentially malicious, because it could be malicious commit, but it could just be an accident. I could have rm-rf in my copy and paste cache, and I could just copy and paste it into a spec accidentally, and that could wipe out the CI server and potentially encode on it. So I definitely think that's an important aspect, and make sure that we treat it securely. In the back. Yep. Yep. No, I did not. But you make a great point, and if for those of you that didn't hear, when you build a project using Travis or one of these other providers, sometimes what they call these things artifacts. There's basically the result of a build. So, like I was saying before, a lot of times people will build RPMs or deb packages based on the master repo. The build server itself might actually be responsible for building that RPM. So there's nothing stopping me from introducing that right into the RPM as I'm being built. So I think that's a great point. I didn't think of that, by the way. Yep. And what's really interesting about your point is that it's not actually going to touch the source code repository. So the source code repository might be clean, but I might Trojan every build as it leaves the door. Yeah, absolutely. Great point. So I don't know how much time I have. Am I over? Okay, 5 minutes.